Um, we are going to solve this problem. Let's imagine that we have a roller coaster. You are here with almost no velocity. The gravitational field will accelerate you. You will increase your velocity. You will go downwards, downwards, downwards. Your velocity will be very big. You will not lose velocity here. And now you will start to lose velocity. You are going up, the gravitational field, the acceleration will go downwards, your velocity decrease, 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 and when you go here, your velocity have to be bigger than zero, because if you arrive here to zero velocity, the weight, the gravitation, will make you to fall directly to the floor, and it will be a big disaster. So you need to have a certain amount of minimum velocity here to be able to go and do the curves, do the rotational, do the motion. And the question is, what is this minimum velocity that you need to have here to produce a motion where you will not fall? So we apply Newton's law. The point P is this one, and we apply Newton's law at the point P. So this is the point P. What are the forces acting on the point P, on the object at the point P? This is the object, the roller coaster. So there is the weight mg going down. What is the other force going downwards? The normal force. The force that the rail is doing on the object. This is the normal force, N. And what is the sum of these two forces? The forces, if I take the positive direction going downwards, N plus mg, it will be the sum. And the sum has to be the mass by the acceleration. But I want a motion that will be a circular motion. So the acceleration is, in a circular motion, is v squared divided by r. But I want the minimum velocity. The minimum velocity that is needed to overcome the situation and to go around the circle. To go around this circle, the minimum velocity happens yes, exactly with the normal is almost zero. If the normal is almost zero, it means that the roller coaster is touching the rail of the roller coaster, so nothing is happening. So this is the minimum condition. So what will be the velocity? 0 plus mg will be mv squared divided by r. So v squared should be r by g. So the minimum velocity is the square root of rg. For example, if for example the radius is 25 meters, let's say that the radius is 25 meters, the velocity that you need at the point P, v of P, is a square root of 25 by 10 meters per second square by P. This is a square root of 250, and this is almost 16, 17 meters per second. So you need to have this velocity to be sure that you will overcome the situation at the point P, and this is the velocity at the point P necessarily to make the circular motion around in the roller coaster. Okay, so let's go to see this another question. What is your apparent weight in the equator, and what is your apparent weight here? It's different, your apparent weight, so it means that the normal is different. Let's go to study why this is true. Why this is true? because we will see that at the equator, the normal force is smaller than here. Okay, why? Why? This is interesting. The Earth is rotating. So the Earth is rotating in a circle of radius r, the radius of the Earth. So if you are here at the point P1, let's going to call this point the P1. If you are here, your mass M is here at the point P1, and there are two forces acting on you. The first force is the weight mg. Is going to the center. The other force is the surface of the Earth is doing a normal force, going to the right. And the total force must produce an acceleration going to the right, because this is a motion with constant acceleration going to the center. Going to the center. So you need to have more weight to the right, to the left, that normal to the right to produce acceleration to the right. So what will happen if you apply, this is the acceleration going to the right, if you take the positive direction going to this direction, so you will apply Newton's law and you will say the sum of all the forces equal the mass by the acceleration. The sum of all the forces will be mg positive, going in the positive direction as the acceleration, minus n negative direction, equal m by a positive. So your normal will be mg minus ma. And how much is a? A is v squared, the velocity of the Earth, divided by the radius of the Earth. You have done this problem, so can you solve the normal is smaller than the weight in a fraction of ma. So you can calculate the differences. Now, if you are here at the top of in the North Pole, the weight will be like this, and the normal force will be up. So the Newton's equation will say that n positive minus mg negative. It will n by a, but you are not accelerating. So n by a will be 0, so the normal will be mg. So at the pole, your normal force at the pole will be mg, while at the equator, your normal force will be mg minus something. Can someone tell me, if your mass is 100 kilograms, what is the acceleration of the Earth? V squared divided by r. Can you make 100 by v squared divided by r to see how much is compared to 100 by 10 from the 1000? How much is the reduction? Can you do it? Yes, you can do it. Try to do it. Now we are going to review what is a bank highway. Why they build the bank highway in the way that you can take the curb with a higher velocity and no risk to take the curb. And so there is a velocity, a certain velocity that you can take here. So what is happening here? This is the weight of the object. So this is the weight of the object, mg, and this is the normal force. The normal force. Then the normal force the object will not accelerate upward, will not accelerate up, and will not accelerate this line, will not make acceleration up or down. So that means that the normal force have to be in that way that the normal force, the component of the normal force in this direction, in the y direction, will be cancelled with the weight. So in this case, the other component of the normal, this force, or this one that is here, the normal component, will produce the acceleration going inwards and will produce the circle, the motion in a circular motion. So let's go to analyze this mathematically. Let's go, this is the angle theta. Theta is this angle here, theta. So n cosine of theta is this part, n cosine of theta, and this part is n sine of theta. So the n sine of theta will produce the acceleration going inwards to produce a circular motion. And the n cosine of theta will be cancelled with the mg that is going downwards. So what are the equations? I will choose this axis. This is the y-axis. Let's go to put the y-axis. And this is the x-axis. Okay. If I do it like this, well, on the sum of all the forces on the y-axis, the sum will be 0 because the bus is not flying on the air and it's not going downwards. So the sum of the forces in the y-axis will be 0. What forces are on the y-axis? I see n cosine of theta going upwards. I will choose the positive direction going upwards. Okay. I also see the mg going downwards. And the sum should be 0. So n cosine of theta should be mg. Perfect. The other force that is here is the force that exists in the x direction. I will choose the positive direction in this direction. X positive in this direction. So an x will be the mass by the acceleration. So nx will be the mass, the sum of all the forces in the x direction is the mass by the acceleration. What is the sum of all the forces in the x direction? Nx. What is nx? Nx is n sine of theta. And is equal to the mass by the acceleration. What is the acceleration? Let me erase here. The mass by the acceleration. What is the acceleration? The acceleration of a circular motion. mv squared divided by r. So I have two equations. In the first equation, n cosine of theta is mg. If I introduce the n equal mg divided by cosine of theta, if I solve for n, and I plug in this n on this nx, this will have n equal mg divided by cosine of theta. And the other equation says that nx, which is n sine of theta, is mv squared divided by r. Okay. But the n is mg divided by cosine of theta. Multiplied by sine of theta will be mv squared divided by r. But sine of theta divided by cosine of theta is tangent of theta. So this will say mg tangent of theta equal mv squared divided by r. The m will cancel. So the v square, the safe velocity to take this curve is when b squared is r, g tangent of theta. If you take the curve with this velocity, nothing happens. The object will follow the vector nx. This force nx will make you to produce a perfect circle. If you take it with a higher velocity, you are at risk. But at this velocity, v equals square root of rg tangent of theta, you are safe. Let's go to do one calculation. Let's say that the radius r is 20 meters. Let's say that the angle theta is 45 degrees. So tangent of theta is tangent of 45, which is 1. What is the velocity that you can take this bank? This bank. Theta is 45. The radius of the motion that you are going to produce is 20 meters. At what velocity you can take it? A square root of 20 by g is 10 by 1. A square root of 200 equal a square root of 13, 14, something like this, 30 meters per second. You can take this bank highway with no problem, and you will move with this acceleration going to the center, v squared divided by r, v squared divided by r, and nothing will happen. Okay, that's all. And the summary is like this. Do not expect that object has to move in the direction of the force. The force changes the magnitude of the velocity or the direction of the velocity, but not necessarily the object will have to follow the force. This is the conical pendulum. We will see this with a lot of detail in class, but it's something very, very similar at what we have done. The conical pendulum, this is a conical pendulum. Everything is rotating, it's like a pendulum, everything is rotating in the plane. This is the plane of rotation, and the plane of rotation is maintained fixed. That it means that the object is not going out of the plane. It means that there is no total acceleration upward or downward. Okay, so if we apply Newton's law to this problem, we can get some conclusions. So this is the tension T. This is T cosine of theta. This is the angle theta. This is the same angle theta. This is T cosine of theta. This force has to be equal to the weight, because if this force is bigger than the weight, the plane where the object is rotating will be higher and the angle will be increased. If this is equal to this, if the tension, the component of the tension vertically is equal to the weight, the object will stay on this plane of rotation. So T cosine of theta have to be equal to mg. So what I'm doing is the sum of all the forces on the y direction equal the mass by ay. What is the sum of all the forces? It's T cosine of theta up minus mg going down equal mass by acceleration. Acceleration equals 0, ay equals 0. So mass by ay equals 0. So I produce this equation, T equal mg divided by cosine of theta. Now I will apply the equation for the x-axis, and I will choose this x-axis. It's exactly the same that I did with the this is the x-axis, as this is the component of the tension in the x direction. So it will be t sine of theta. This is t sine of theta. This is the magnitude of t by sine of theta. It's the only force, so the sum of all the forces in the x direction is the mass by the acceleration in the x direction. What is the sum of all the forces in the x direction? T sine of theta. Equal the mass by the acceleration, but this is a circular motion, what it's doing, so the acceleration is v squared divided by r. So if I play with this equation, you will find that v squared is the same equation that before, v squared equal rg tangent of theta. So play and find this. Okay, we leave it here. I wish you can see this slowly, analyze, think about it. I think you will catch it.